Yeah.
So we're looking at number 6, which is asked, what is the inductance of the solenoid? So we're going to start off with the equation first. To find the inductance of a solenoid, we got L equals mu naught times N squared, which N is the number of coils, number of times the coils are going around, times A, which is the area, which is pi r squared, which is R is the distance between there to there, and then we have divided by L, which is the length of the solenoid. So once we get to the numbers, mu naught is a constant, N, which is given, is 2,000 times coiled around squared. The area is pi times 0.03 meters, because we know the radius is 3 centimeters squared, and then we have divided by the length of the whole thing, which is 15 centimeters. When you do all the math there, you get 0.095 hertz, which ends up being 9.5 times 10 to the negative 2 hertz.
Alright, so we're trying to find the amplitude of the voltage across the solenoid. So we start off with using Faraday's equation, which is inductance times the derivative of current with respect to time. So we have our current, which is 0.2 sine of omega t, and then take the derivative, which ends up being, you end up getting 24 pi cosine 120 pi t.
So now that we found the IDT, we can use that number and this that we found in the previous problem, and then put it in for L. Then we multiply it to be 0.095 times 24 pi cosine 120 pi t. But since we're finding the magnitude, we can set cosine of 120 pi t equal to 1, since that's going to be the greatest value for cosine. And then after doing the math, we end up getting 7.16 volts, which rounds up to 7.2 volts.